Okay, so we did a little overview of Bohr diagrams and Lewis dots, so we're going to go a little bit more in depth today. I want to do it more on the practice side. So last time you learned that electrons exist in different energy levels. They depend on the number of protons that there are in an atom, because not protons and electrons will always equal in a neutral atom. You've learned that valence electrons are the outermost electrons in the element. So valence means outermost. So we're going to go over how to do the Bohr diagram, how to do the Lewis structure, and how to find out how many valence are in the shell. So of course, our Bohr diagram is just like we have with our Bohr model. You have your nucleus, and then you have your energy levels outside of the nucleus. Nucleus, energy levels. So let's start with hydrogen. Hydrogen is first, so it only has an atomic number of 1, meaning that there is 1 proton. Because there is only 1 proton, that means that there is only 1 electron. So in this case, we have 1 proton in our outermost shell. So next we have helium. Helium is number 2, so it has 2. So we will write 1, 2. So we have now filled our first energy level. So helium is the only atom that will have just 2 in its first neutral atom. Lithium. Lithium is 3. So if we go on, but wait, we know that the first energy level is only 2. So that means we need to add another energy level. So by adding this another energy level, we now find out that there is only 1 valence electron in lithium, because we could have up to 8, but we know there's only 1. So that means there's only 1 valence electron, even though there are 3 total electrons. Because remember, our first energy level can only hold 2. So when you run out of room on the second, you then create a third. When you run out of room on the third, you then create a fourth, and so on and so forth. So we won't worry about D and F for right now, because these are hybrid levels, and we'll explain it later on. All right, so Bohr diagram. First energy level, 2. Second energy level, 8. Third can hold up to 18 electrons. All right? It can hold 8 electrons. That's a bad mistake. I apologize. Let me pause this real quick. Fixed. So first energy level 2, second energy level 8, third energy level 8. We'll go on from there. So all you have to do for Lewis is just find the valence electrons. So this means we're only doing the outermost electrons in an element. So this works better for things that have many electrons. So if we go all the way down to iodine, we know that iodine is in group 17, so it's going to have 7 valence electrons, because group 17 has 7. But it has a total of 53, but it makes it so much easier just to do the Lewis dot structure. So the amount of dots you draw around a Lewis dot structure is equal to the number of valence electrons in the atom. Remember that it is dictated by the group, so we go by the group. Groups are vertical. Remember the columns. 1 and 2 have 1 and 2. Then we go to 13, 14, 15, 16, 17, 18. They all have the same amount as the second number in their group number. So if we have, you like my little pun here, first 2 are very tricky, so pay attention. First group, 1 valence electron. Second group, 2 valence electrons. So the only difference is we can move helium to group 2, because we know it has 2 in its outermost shell. It is a noble gas, so it is in group 18, but we know it can only hold 2, so it's filled up. So it is the only one that is the exception to the rule. But technically, in this case, we can move it to group 2 just to make it safe. So group 3 has 3, or group 13 has 3. All right. So if we do group 13, it has 3. I need to fix that as well. So the only thing that we need to worry about is that if we do group 13, 14, 15, 16, 17, 18, we just take off the 1, and that'll tell us how many valence electrons we have. And that just means our structure is then 3 dots around the symbol. And that's it. All right, that's it for today.